Thank you, everyone. So, as Brian mentioned, my name is Aditya, and this talk is titled Goro, Translating Go to Other Human Languages and Back Again. I'm a systems engineer at Stripe, which means that my job is to write open source software for monitoring and reliability. I've been writing Go full-time for the past 5 years now, and a lot has changed in that time. This right here is from the source code of the Go 1.0 compiler back in 2012. So if you don't write C, there's a lot of unfamiliar stuff there. You might be able to get a sense of what's happening, but not completely. And it would be much harder to actually write that yourself than just to read it. And this was a huge barrier to contributing to the Go project, and everyone recognized it. Like, think about it. We're here to contribute to the Go project. We already know and use Go, so why do we need to learn a whole different language, C, just to contribute to Go? So we rewrote the entire Go compiler from C to Go, and that was released in 2015. We did that largely with a C to Go translator that translated the code automatically, and the rest was done by hand, little fine-tuning fixes here and there. And there's a great talk from the very first GopherCon about this process. But that only removes one language barrier, and there's still one more to contributing to Go. Go development happens almost entirely in English. That's true both of the official Go project, but also of popular projects that are written in Go, like Docker, Kubernetes, Grafana, all the ones that you saw Steve mention this morning. Almost all of those are developed exclusively or primarily in English. And so a person's ability to contribute to those projects is greatly limited if they don't at least have a working grasp of English. And like even reading the code, like understanding what char and scale mean, that's something you and I might take for granted, but for some people, even reading the Latin script is an extra challenge. And so computers are here to make our lives easier. They're here to do the work for us. So let's see what computers can do to fix this. And in the Go community, we already have a lot of people who don't speak English as their first language, or don't speak English very fluently, or in a few cases, don't speak English at all. So for example, the Chinese Go community, there's actually a large Go community in China, and for various geopolitical reasons, it's fairly separate from the mainstream English-speaking one. And so they've translated the official Go documentation into Chinese, like complete with the iconic Gopher mascot. And there are projects that you can find on GitHub where everything from the README and issue tracking to even the comments and the variable names all are done in Chinese. And GopherCon Brazil is a bilingual conference, and it has talks in, it offers some talks in English and some talks in Portuguese. So it's great that Chinese and Brazilian Gophers have developed these thriving communities for themselves. But we also know that fragmenting resources is bad for open source development. Fragmentation means duplicated work and incompatible interfaces. So let's think how we can actually bridge these communities. And one possible approach, you can think of this as the null hypothesis, the straw man, is to use a common language. That's also known as a lingua franca, which comes actually from the so-called Frankic language Sabir, which wasn't actually spoken by the Franks. Go figure. If we wanted to standardize around a single language as our lingua franca, English would be the most reasonable choice because it's already so widely used by open source projects and by the Go project itself. But that poses a lot of problems. I mean, primarily, English is difficult to learn, and objectively, that's why we have the situation we have now, where it's actually easier for non-speakers and non-native speakers to build their own communities, to reinvent the wheel, than it is for them to participate in English-speaking ones. And even if everyone could just learn English, non-native speakers are always going to be experiencing a language barrier that native speakers aren't. And that goes against our goal of having the same level playing field for everyone. But finally, and most importantly, we think of English as a single language, but in reality, there are many different dialects and registers. So if our solution is to use a single language, we'd have to standardize around these as well, and that's impossible to do. This is one of the reasons that the very first lingua franca, Sabir, died out. It's not that it died out as much as its usage grew across the Mediterranean, it got fragmented, and it ended up influencing and getting absorbed into the local languages like Portuguese and Italian and Spanish. And so it's much better for us to embrace multilingual workflows instead of fighting an uphill battle against linguistic divergence, which, I mean, linguistic divergence has existed as long as we can tell from everything we studied about human languages. And it's no accident that we already do embrace multilingual workflows and design around linguistic divergence for programming languages too. Go is a little bit young for this, but we can look at another language that's similarly popular and used on multiple platforms, JavaScript. You know, it's been 22 years since LiveScript was first released, the very first version of JavaScript, and its usage has expanded to use cases we could never have even imagined back then. It's used both client-side and server-side, and it's used in a number of different contexts. And as we keep expanding those, we've noticed things like CoffeeScript or TypeScript pop up. And even though those might be separate languages, writing, say, Node.js on the server is very different from writing, React or writing React Native to run on iOS, which is very different from writing pure JavaScript without any jQuery back in 2001. And those are all, yes, the same language, but we start to see that as the usage and as the needs grow, languages diverge. And so we need to be able, we already do this for programming languages, we should be able to do this for human languages as well. And the idea of eliminating natural language barriers to programming isn't new at all. In fact, it's very old. Grace Hopper is one of the very first computer scientists, and she wrote the very first compiler for a high-level programming language. And the language that she invented was called COBOL. The goal with COBOL was to have English-like natural language syntax so that business executives could write code. And yeah, I hear some laughs about that. Probably some people who've actually seen some COBOL in the wild. But she received a lot of pushback with this goal at first, because engineers are furious. They thought, well, if non-engineers can write code, this could put us out of a job. But Hopper's vision took this even further. Why restrict this to English-like syntax? What if engineers who spoke other languages wanted to write programs as well? She wanted COBOL to be, and I quote, a language you can use to talk to programmers around the world. And the response to that was even more vitriolic. They said, well, how can we teach American computers to run German programs? And to be clear, this wasn't a question of how it could be done technically. This was a decade and a half after World War II, and the fear of a threat from Germany or Russia still looms strong in people's minds across the Allied nations. But even if Hopper's idea was put on the back burner due to xenophobia and politics in the 1950s, we can look at what it means today and learn from that approach. This is Hopper speaking about COBOL many years later. She said, I would have thought it would be useful to NATO because they had the common verbs for the things they were going to do. And the nouns, they just have to have a dictionary for things they were referring to for inventory control. They'd have common nouns throughout NATO, and they could make a dictionary of common verbs and translate the program. You could write one in English, and you could translate it, and it could go to the other language. No problem, you'd have communication. It would be a limited vocabulary. And as an interesting side note, Hopper chose the imperative mood for COBOL specifically because she believed that the imperative would be universal to all languages. Not all languages distinguish between present, past, future tenses, but languages do generally have a way of commanding people to do something. And COBOL was one of the languages which popularized imperative programming styles in the first place, so this has actually stuck with us to this day. Notice how even in Go, everything from function names to keywords, they're usually in the imperative, and that's indirectly a result of this tradition. There's also, as a piece of trivia, one other thing that Go takes very directly as an inspiration from COBOL. Does anyone know what it is? I don't see any hands. OK. So it's the time parsing function. So in Go, the way that you parse a time is you give the canonical reference time in the format, specified in the format that you want to parse, and then you give it the value that you're trying to parse. And Go will figure out how to match those two. And that's modeled 100% after COBOL's picture clauses. So let's see what we get when we take the techniques that we use to translate the Go compiler from C to Go and apply those to Hopper's vision today in 2017. To do that, we can look at Goro. Now, Goro is an extension of the Go compiler and toolchain to support Bengali. Oops. So the extension of the Go compiler tool chain to support Bengali. And the name Goro is an idiomatic translation of the English name Go. Now, I chose Bengali because, for a few reasons. First of all, it's a language my family speaks, so it's a language I know. In addition, after Hindi, it's the most common language spoken in India. It's also the national language of Bangladesh, which combined makes it the 7th most widely spoken language in the entire world. In addition, it's also a language that's really good to study for this purpose because it's a language that uses a script that's not the Latin script, and particularly a script that has, for lack of a better word, diacritical marks. So you can think of those like accents or umlauts in Spanish and German. And in Bengali, you have a lot of these modifiers. Even vowels are actually like right there. That vowel at the end is a modifier on the character that comes before it. Fun fact, if you look in your program today, this renders correctly here and on the website. If you look in your program, the title for this is actually spelled differently, and it's spelled in what is to native Bengali speaker sort of a nonsense way. So getting all of these things is correctly and getting them displaying correctly is actually a difficult battle. So if we can demonstrate that and do that with Go, we can be relatively confident that it will work for other languages that are also not very similar to English. But nothing that I'm presenting here is unique to Bengali. So if, for those of you who speak languages that aren't English, I encourage you, go home and try to do this with your own language as well. So we'll start, this is a familiar HelloWorld program that's written in Go. We know what this looks like. And this would be the equivalent program that's written in Goro. Now, we've left the identifier names intact, but the keywords are now in Bengali. And if you're looking at this and thinking that, with eagle eyes and thinking that I missed something, no, true is actually not a keyword in Go. It's actually defined separately. So we did actually translate all the keywords. But the first challenge with this is we need to actually get this to run. Like it's all fine and well for us to write this, but right now it's just text on a page. The standard Go compiler won't actually know what to do with these keywords. So a quick show of hands. How many of you are familiar with what a lexer or parser are? OK, I see at least some hands that are not raised, so like the 30-second explanation. A compiler front end is divided into two parts, two stages. You first have the lexer, and then you have the parser. The lexer, you can think of that like tokenizing a sentence or a paragraph. It's a relatively easy task with like a few little quirks in it. Like you can more or less split on white space, but then you also need to be able to handle punctuation like contractions for the word don't. Or something like, Mr. Smith. You want to be able to make sure you handle that period correctly. And maybe, let's say you don't want to tokenize anything that's inside parentheses, so you have to make sure, or a quoted string, so you have to handle that correctly. But it's a pretty straightforward task, and you're really just taking everything and splitting it up into the individual tokens that then get handed off to the parser. And the parser is where you have to actually interpret it and apply the semantic meaning and figure out, okay, fine, this is what these tokens combined together actually translate into and what the intention is with that code. So the lexer is a much simpler stage of the process, and the parser deals with more complex transformations. So Go's source code is all UTF-8, so the compiler has no trouble dealing with non-ASCII keywords in Go programs. And remember that now the Go compiler is itself written in Go and not C, so the Go compiler has no trouble dealing with non-ASCII keyword definitions. So there are a few internal checks that ensure that non-Latin and non-alphabetic characters are not used in keywords, but it turns out that you can actually just disable those tests and nothing breaks. So all we have to do then is extend the lexer to handle the Bengali translations of each keyword, which is what we just did here. And so you can see here that every single word, it still maps to the same value, which is actually an int32 defined as constants. But we're just changing or adding different keys that map to the same value. The parser, as far as the parser is concerned, nothing has actually changed. And this is something that you can't actually do in most other languages which use flex-based lexers, because lex and flex don't support multi-byte code points. So as a rough analogy, you basically can't, because each of these characters is more than 1 byte wide in UTF-8, you can't just have them lead to the same exact value in the map. You need to be able to teach the parser to say, okay, fine, these combinations of like 3 tokens put together all are equivalent to that same 1 token. And then once you start touching parser logic, it's much easier to mess things up, to actually change the way that your code executes and runs. By keeping this logic entirely in the lexer, we can be 100% sure that nothing about the semantics of our code change, because the parser literally is receiving the exact same input that it received before. And so there's a reason that I'm giving this talk at a Go conference and not at a Python conference. I mean, it's true. I love Go, and I've been writing it for 5 years, and there's a reason that I, in general, speak at Go conferences. But more than that, this is literally not something you can do in Python, at least not so easily. And even in the original Go compiler, which was written in C, it would have been much harder because it didn't have this native support for UTF-8, and it didn't have a pure Go lexer and parser. And so, by the way, some of these translations were straightforward, and some were really fun to do. I think my favorite was fall through as a keyword. So, like, for those of you who speak languages that aren't English, try and think how you might translate Go keywords into those languages. When you start getting things that are idiomatic, like fall through or go to, you can think, well, do I try to translate the idiom? Well, what if there's not an idiom that matches? Do I do it literally, or do I try to find something else that means something else but conveys the same meaning? It can get quite interesting. So now, having made those changes, here's what that HelloWorld program looks like in practice, written in Goro. So we start off with this, and we run it. Pretty simple. But remember, our goal is to defragment the open source community, not to fragment it further. So we want to make sure that our code is interoperable with code that's written by English-speaking Go developers. And we don't want to have to translate every program manually. So as for the translation step, Go already has a handy utility for formatting source code called Go Format. Or if you're one of those weird people who pronounces it Go Fumpt, you could call it Go Fumpt. And mostly we used it to prevent byte shedding over things like tabs versus spaces argument. So instead of arguing over the proper way to format source code, everyone can just set up their editor the way they want. And if I want to write 4 spaces to indent everything, and you want to write 2 spaces to indent everything, Go Format means we can still actually work together. Because we just set up our editors to render tabs with the width we want, and then write the number of spaces that we want to indent with. And after we save our code, we run Go Format, and it automatically translates our code to the standard style. There's no work that's needed. In fact, we don't even need to be aware that we each have separate indentation preferences, neither of which, by the way, is the standard one, which is to use tabs, because the code that gets committed is still in the standard form, and then our editors just display it in our preferred forms. And Go Format can handle a lot more than just white space modifications. Like, it can do things like removing unnecessary parentheses or other simplifications. And it's syntax aware, so it's smart enough. It will never change the semantics of your code, which is a great way of saying that it's a built-in utility for performing fully isomorphic translations of source code. And so we can extend it and repurpose it for translating English Go code to Bengali or Bengali Go code into English. And that's what Kora Format does. So let's translate that same Kora HelloWorld program back into English Go. So we start off with the Kora program, and we run Kora Format. And we get the English Go program. And just to prove that we haven't changed the semantics, that the regular standard Go compiler is able to run it, let's do that as well. There we go. I think that deserves a little bit more excitement than that. We just translated Go from one language to another and back again. So the same way that you didn't know that I was using 4 spaces and I didn't know that you were using 2, having bidirectional translation layers means that you don't need to know that I'm writing my code in Bengali, and I don't need to know that you're writing your code in Chinese or in Portuguese or in Russian or whatever language. because we can localize our source code as a commit hook the same way we format it as a commit hook. And so as a developer, Goro means that you only ever need to look at source code in your own preferred language. And so as far as the code is concerned, our language preferences are no more of a barrier between you and me working together than our indentation preferences are. And that's the way that it should be. The computers are doing the heavy lifting for us. So we've translated the keywords, but you'll notice that we didn't touch everything yet, like the package and the variable names. And now there's been a lot of ink that's been spilled about the topic of choosing good variable names. And the one thing that everyone seems to agree on is that they should be both somewhat descriptive and somewhat concise. But of course, if we leave the variable names in English, as most open source projects do, that's not going to be very descriptive to someone who doesn't speak English. So is there a way that we can actually translate those as well? Fortunately, in reality, many variable and function names are already highly structured. To put it in Hopper's language, we already have the verbs that we use quite frequently when writing code. In Go, for example, read foo or write foo, close, these are all verbs that are used commonly not just across the standard library, but in other packages as well and in different contexts. And so we can take advantage of this knowledge and translate those in the translation step as well. And Go Format already gives us the building blocks to make renaming transformations like these. We just need to be able to specify how to translate them. And now we might not be able to get to translate everything. As you can see here, we can't translate what foo is, because foo could be anything that's arbitrary. But we still can say that read and write should be translated to boro and lekho. And so someone who speaks Bengali can understand, well, okay, this is at least reading or writing something, and then they can look in the surrounding context to figure out what foo actually refers to. And so by being just a little bit more conscious about the conventions that we're already using, we can make our code much more accessible to English speakers. And even if we don't get all of those translations completely for free, we can still get many of them. Now, for many of us, coming to Go meant getting used to a completely different strategy for error handling. And instead of throwing exceptions, we return errors. And it's true, that does take some getting used to, but eventually we learned that there are some amazing advantages to this approach, as Rob Pike's blog post, Errors Are Values, goes into. And that statement, errors are values, can mean a lot of things. It means that we can assign the return value of a function and operate on it as a first-class citizen of the language. It means that we can store it on a struct to record it and query it later. The scanner package in the standard library does this. It also means that we can ask that type what other interface types it also satisfies, which, if you'll notice, sounds very similar to asking it what other languages it actually knows. And Go's error handling is probably the most expressive error handling system of any language I've ever used. It's right up there with Common Lisp. And I've spoken previously about interface types and error handling, so if you're interested in hearing more about ways to take advantage of Go's error handling system in general, you can check out those videos. But for today, treating errors as values lets us do something that's very relevant to translating code, which is we can localize our error messages. In Go, the string that's returned by the error method is the only value that you can ever guarantee is available for every single error that you will ever encounter in a Go program. And it's considered bad form to try and parse this error string, in code. And I would strongly agree with that as a matter of coding practice. But because it's considered bad form to try and parse it automatically, that makes it all the more important for us to be able to render error messages in a way that's actually readable and interpretable to the developer who's going to be encountering them. Because as developers, we've all struggled with cryptic error messages, and this is one of my absolute favorites from Java. Cannot cast parameter type from type system.string to argument type system.string. Does anyone know what this actually means? No, I'm actually seriously asking this. I haven't written Java in so long, I've actually forgotten what this even refers to. Yeah, see, I have no idea. Neither does any single person in this entire room. But, and I will say that Go isn't immune to this either. We're picking on Java, but like if you ever think that your coworkers are just, getting too much work done on a given day, just like ask in your company Slack, what's the worst error message that you've had to debug in production? And like instantly you've nerd sniped your entire company, their day is shot. Seriously, try this at home. But the only thing that's worse than a cryptic error message is a cryptic error message in a foreign language that you can't even understand. And so error messages are a good starting point for what to translate, because not only are they finite in number because of the way we define them in code, but translating them will have a huge impact on your collaborators as well. And they're the easiest to solve technically because we can leverage existing localization strategies, which is a very well-studied and well-understood topic. Most languages already have libraries that assist with this, that will provide variants of specific textual strings depending on the designated locale. And they can assist with things like pluralization or capitalization rules, which are not always going to be the same across languages. Internationalization is something that's often abbreviated as I18N for the number of characters elided there. And so the Go library for this is creatively titled Go I18N. I guess they did not listen to Matt's talk about how you don't need to, announce that it's a Go package, but it's there. And if you want to do this, it's a great tool that you can leverage. But again, our goal ultimately is to be able to do all of this automatically. And translating error messages by hand might be fine, but translating documentation will start to get really tedious, and it'll be hard to keep that up to date and in sync. I'm sure I'm not the only person who's ever amused themselves by trying to use Babelfish or Google Translate to see how machine-generated code will stumble over idioms and words with multiple meanings, like fall through or something like that. But it turns out that Google Translate can actually work quite well for technical documentation. If you ask Russ Cox, he'll tell you not to use C2Go for other projects because it's not designed to work on all C code. It's just designed to work on the type of C code that was written for the Go compiler from 1.0 to 1.4. And that's a very narrow subset. And similarly, we're not looking to translate all English to another language and back again. We're just looking at translating our open source software and its documentation, both the code and the documentation. And as it turns out, automatic translation does work very well for specialized and technical text, as well as text with narrow context like that. Wait. Here we go. So here is some documentation from the standard library from the IO package. And here's what that looks like in Bengali. Now, of course, if you don't read Bengali, this doesn't look very impressive. Like, I could tell you, yeah, this is a pretty good translation and ask you to take my word for it. But, that's a bit anticlimactic in a talk like this. So, short of trying to teach you all how to speak and read Bengali in the next 40 minutes, let's just see what happens if we try to translate the Bengali text back into English and use that as a proxy for how much information we're losing in each translation step. So there are some amusing errors here, like code at the beginning, but you do generally get the gist of what's going on. Like the information is copied directly from the corresponding text or text. There are no internal buffers. I didn't touch any of this, by the way. The punctuation, the capitalization, all of that stuff is exactly what Google Translate provided. And keep in mind, Bengali doesn't even have capital letters, but they were still translated back correctly from the context in the package. And so, okay, fine. Maybe you're still skeptical about this. Maybe this, think this was just a fluke. So let's try translating the original text into Bengali, translating the Bengali text into Spanish, and then translating it back into English. So we're starting from a Germanic language, going to an Indo-Sanskrit derived language, then jumping to a Romance language, and then going back to the original Germanic language. And I'll say, this isn't great. This isn't the best documentation that I've ever read, but I've definitely read documentation that's worse than this. And I've also definitely used a lot of projects that had no documentation at all whatsoever, and I would much rather deal with this than deal with the one-liner documentation that just repeats what the function name is and doesn't give any more information, or doesn't even bother to have that. And you can still get things like, relevant text information or text is copied directly from the site. There is no internal buffer. You can still get the gist of what's going on there, and it's a good starting point for someone who wants to then, fix it up later on. My favorite thing actually here was how the individual calls will be gated sequentially, got translated into the door will be in the order of personal calls. I don't know. But it's true that automatic translation for this stuff isn't alone going to be good enough. That's what people already do, and I mean, we saw the numbers. It isn't working. And that's because relying on machine-generated translation, it makes for a really alienating experience. It doesn't make people feel welcome or encouraged to participate if they're forced to, take the documentation and paste that into Google Translate themselves or, use a browser extension. I surveyed people who didn't speak English as a native language a while back when starting this, and this was a very common point. One of my coworkers actually said that when he was first learning to program from French websites, it took years before he felt comfortable participating in English-speaking ones. And he did speak English, but he didn't feel comfortable or welcome participating in those English-speaking online help communities because he was a non-native speaker and he felt that barrier. So the goal with automatic translation with documentation is to plant the seed. You're signaling that your project is thoroughly multilingual and that you're excited and interested in having people from other linguistic backgrounds come and participate and work on your project. And once you've planted that seed, you may be surprised by how many native speakers of other languages are drawn to your project, but you don't have to wait. You can actively reach out within your project's community because you might not speak Spanish or Russian or Hindi, but there's a good chance that someone who already uses or maybe even already works on your open source project does. And if you go to almost any conference that's organized around a specific piece of open source software, you are almost guaranteed to hear a talk on how to encourage more people to contribute to the project. That we actually hit that, you can play bingo. We hit that with the very first talk of this day, the opening keynote. Like at Denver for GopherCon last month, we had an entire day that was dedicated to getting people, a workshop dedicated to getting more people contributing to Go for the first time and getting them onboarded with that entire process. And we started off with getting people to, I was a mentor for that. We started off getting people submitting examples or documentation fixes as a good first commit. But it turns out that asking for community translations or to improve community translations that might have been automatically generated at one point is a great way to get people to make that jump from being a user of a project to getting their first commit in. And the key here, though, is that you actually have to ask. You have to seek it out. And it might sound obvious that I'm saying it now standing here on the stage, but it's not something that your users are going to think to do unless you make a clear point of it. Because for all they know, that's not something that you want to do. And you don't have to do anything overly elaborate with this. You can create project milestones and file issues in your issue tracker and label those tickets by language so that people can easily filter and see what's needed. Like, this is what that could look like. You tag this with docs because all the issues, all the tickets relating to your documentation are tagged that way. But you can also tag it with Korean so that someone who speaks Korean can actually filter and see, all right, these are the things that I can actually contribute to very easily first off. And a lot of key project communication happens over mailing lists, and it'll be very hard for developers to be first-class citizens in open source development if they can't participate in conversations around project direction or just other technical discussion. And even non-native speakers don't always feel welcome as participants in developer mailing lists. So just as a thought, what if we actually encourage people to participate in developer mailing lists by writing in their native languages, if that's the way that they feel that they can best express their thoughts? Just as with documentation and errors, there's a good chance that there already are other people there who are willing to help bridge that gap and translate it or summarize for them and serve as relays. Encouraging people to write in their native languages, it's also a great way to encourage people who do speak English but are non-native speakers to feel more comfortable using imperfect English on mailing lists as well. Because again, it establishes the project as thoroughly accessible to people of all linguistic backgrounds, and it assuages the fear that non-native speakers may have when using what's for them a second language. So the same way that Wikipedia offers alternate versions of an article in different languages and gives you a way to switch between them, we could do the same thing on our mailing list archives. And this is just a mock-up. This is what that might look like. This is the archive page for a German language Debian mailing list. And so Debian has a number of mailing lists for the entire project, and they have non-English ones which are classified separately. But instead of classifying them completely separately and segregating them, what if we provided links, as you can see right there at the end, ES, EN, Chinese, what if we provided links to community translations next to them the same way that Wikipedia does and allow people to extend them and augment them? Even if every message won't get translated into every single language, it provides the space for that to happen when needed, when that message does actually need to be read and understood by multiple people. And again, we already have all of this information happening and duplicated, as we saw at the beginning. Like, Chinese, Portuguese, we already have different mailing lists and different parts of the Go community, the global Go community, that exist in different linguistic spheres, but they're all fragmented and scattered across the internet. It's much better to centralize this within the project archives than it is to force non-English speakers to replicate it themselves elsewhere and duplicate that work, or to fragment developers into language-specific groups, or, worst of all, to entirely preclude them from participating in the first place. So there are a lot of different steps that we could take to including non-English speakers in open source Go development. And making tool chains for translating code and documentation to other languages, like we saw with Goro, is just one of them. So if anyone's interested in going home and making a variant of Go like Goro for their own language, or working on a tool for providing community translations of documentation, or any of the stuff that I mentioned, I highly encourage you to do it. In fact, come talk to me. I can help you get started. It's a pretty easy process. And some of these approaches do involve building new technology and tools to solve the problem, but there are a lot of other straightforward and low-tech things as well. As you've seen, they involve the way that we actually operate as a community and interact with each other, not just the technical stuff. To some extent, the technical stuff is actually relatively easy. We saw writing Goro was pretty quick, but actually integrating that and getting people's workflows and getting people on board with that's where the real challenge starts. So we're just scratching the surface here. And for any of this to happen, we need to commit ourselves to doing it. To get a sense of the importance, we can look at this visually. That oval shape right there, it's actually a circle. It's just a map projection that makes it look distorted. But on a globe, it would be perfectly circular. And that circle, which is pretty tiny on the globe, actually represents more than half of the world's population. More people live inside that circle than live outside of it. 1/5 of the world lives in China alone, and another 1/5 lives in India. And those aren't the only places where we have people who might not speak English or might not speak English as their native language and still want to be able to participate in open source development and be a part of what we're all doing here. We're building open source software because we want to change the world. We think that we have power this way. And we need to remember that 95% of the world doesn't speak English as their first language, and 89% of the world doesn't speak English at all. So this room seats 400 people. If this room were perfectly representative of the entire world, then only 44 people would actually even be able to understand what I'm saying. And of those, all but 20 would be listening to me speak in what's for them a foreign language. So between UTF-8, native UTF-8 support in Go source code and Go format for isomorphic translations, and also already having a large community of bilingual or non-English speakers, there really is no other language that's as well suited as Go is to being used by the entire world, not just the 5 to 10% who currently speak English. And we have an opportunity to bridge the language divide in a way that no other programming language has ever been able to do. So let's do it. Let's make Go the first programming language that's truly accessible to everyone, no matter what language you speak. Thank you.
Wow, that was impressive. Anybody have any questions? Yep.
Hi, Aditya. What about just doing a simple kind of find and replace rather than getting into the Lexa and stuff? And what about having a project that is just a map of all the keywords in every language? Is that a good place to start?
Sorry, a find and replace instead of what did you say? Instead
of like digging into the Lexa.
Oh, so I mean the answer with a find and replace is that if I run sed and I change package, then anytime that I have a string literal that contains the word package,
So slightly more sophisticated then.
It's more sophisticated, and the key is that it's guaranteed not to introduce any errors. That's why we can do a translation symmetrically and ensure, unlike with the automatic translation that we saw with the documentation, because that's natural language, you introduce noise at each step. If we do this with the compiler, which is a very simple extension, we are guaranteed that we're always going to get back the same thing.
I wonder if you could have the printer, the Go printer, do that in different languages, and you provide basically a map, because all it is, right, the keywords and then the
that basically is it. I did it this way to demonstrate it as a separate compiler. In reality, if we wanted Go to actually do this as part of the official project, that's exactly the approach we'd take, because then we'd be centralizing all the different languages in a single project, whereas this is just a random fork. That's of course, a little bit outside my control, at least mine alone.
Have you thought at all about translating scripts that aren't left to right or top to bottom in the source code?
Actually, this started off when I did a 12-week stint at the Recur Center, which, if anyone's looking for like to take a sabbatical or something from work, highly recommend doing. You can talk to me about that afterwards. So I was at the Recur Center, and one of my batchmates there, he speaks Arabic. He's from Sudan, and that was where we actually started off looking at this. And he wanted to start off by writing something that was based on Python, and we found out very quickly, it's very difficult to do because, first of all, Python uses Lex as its basic lexer, and then secondly, the RTL issue that you mentioned. From Go's perspective, that actually doesn't matter, right to left. It does make a difference in terms of rendering, and that's where things get a little bit thornier because not all, a lot of terminal emulators just don't support RTL, period. And if they do, they don't really properly support, mixing it with left to right languages. So fortunately that's a layer that exists separately from Go. So we can make sure that Go works perfectly with any language regardless of how it's written, as long as you're using an editor that does support those languages.
All right, let's give Aditya a big hand for what an amazing talk.
Thanks.
Our next talk will be at 11:15, and this will be an